Good morning once again. So this time let's have the joint and combined variation. So let's have first the joint variation. So we have there y varies jointly, that's equal to k as x and z. So our equation there will be y is equal to k x z, or we have y over xz is equal to k, where k here is the constant of your variation. So let's have the first example. Suppose y varies jointly as x and z. Y is 32 when x is 8 and z is equal to 2. Find y when x is 15 and z is equal to 6. So we will have first the equation of variation. So we go back to the problem. We have there y varies jointly, that's equal to k, x, and z. So we have there y is equal to k, x, z. So our given will be y is equal to 32, x is equal to 8, z is equal to 2, and we will be solving for the constant k. Now we substitute this given to our equation. So y is 32, k, x is 8, z is equal to 2. So 32 is equal to k. 8 times 2, that's 16. Divide everything by 16. 32 over 16, that's 2. Now we cancel the 16, leaving us the k. So the k here for number 1 is equal to 2. Now find y when x is 15 and z is equal to 6. So we will be using the same equation, but this time we are solving for the y. So k, that's 2, x this time it's 15, and z is equal to 6. So y is equal to 2, 15 times 6, that's 90, and 2 times 90, that's 180. So our y here is 180 when x is 15 and z is equal to 6. So let's have the second example. So the area of a rectangle varies jointly as its length and width. Find the equation of joint variation if a is equal to 60 feet squared, length is equal to 15 feet squared, and width is equal to 4 feet. So let's have the equation of variation. So area varies jointly, length, and width. So the equation here will be A is equal to KLW. So we have there the given. So we have 60 feet squared, length is 15, and width is equal to 4. And we will be solving again for the K. So the same equation, substitute the given. So area is 60, K is unknown, L is 15, and W is 4. So 60 is equal to K. 15 times 4, that's 60. Divide everything by 60. So 60 over 60, it's 1. We cancel. Then K. Now, our K here is equal to 1. Now, find the equation of joint variation. Now, in finding the equation of joint variation, this equation here, we simply change the value of the k to its value. So we have there the k is equal to 1. And since we do not leave numerical coefficient as 1, we simplify further. This is area is equal to length times width. Now let's have this time the combined variation. So we have y varies directly. Again, it's equal to k as x. But take note, this time there's the word inversely as z. So we have here y is equal to kx over z. Or we could have yz is over x is equal to k, where k here is the constant of your variation. Okay, let's have example for combined variation. If y varies directly with the square of x and inversely with z, and y is equal to 1 when x is equal to 2 and z is equal to 10. So find y when x is equal to 4 and z is equal to 5. So we will have first again the equation of variation. So we have y varies directly, square of x, inversely with z. So we have there y is equal to k x squared over z. Now, we have there the given. So we have y is equal to 1, x is equal to 2, z is equal to 10. And we will be solving for the constant k. So the same equation, we substitute the values. So y is 1, k is unknown, x this time it's 2, and z is equal to 10. Now multiply everything by 10. So we distribute this. 10 times 1, that's 10. Then we cancel this. So k, and 2 squared, that is 4. We divide everything by 4. So 10 over 4, that is 5 over 2. We cancel the 4, leaving us the k. So the constant here is 5 over 2. Now we have here find y when x is equal to 4 and z is equal to 5. Again, the same equation of variation. So this time, we will be solving for the y. Our k, we all know that it's 5 over 2. And then our x, this time it's 4 squared over 5. So y is equal to 5 over 2. 4 squared, that is 16 over 5. So y is equal to 5 over 2 times 16. That will give us 40 over 5. Now 40 over 5, that is equivalent to 8. So our y here for number 3 is equivalent to 8. Okay, now let's have the fourth example. So if A varies directly with the cube of B and inversely with C, and A is equal to 8 when B is equal to 2 and C is equal to 4. So find A when B is equal to 6 and C is equal to 2. Again, we will have the equation of variation. So we have there A varies directly, cube of B inversely with C. So A is equal to KB cube over C. So our given here, we have A is equal to 8, B is equal to 2, and C is equal to 4. So we will be solving again for the constant k. So our equation, substitute the given. So we have A is equal to 8, K, B is 2 cube over 4. So 8, or multiply everything first with the value of our denominator, which is 4. Now, distribute 4 times 8, that is 32. We cancel the 4. So k, 2 cube, that is 8. So divide everything by 8. 32 over 8, that is 4. Now we cancel the 8, leaving us the k. So our k here is equivalent to 4. Now, find A when B is equal to 6 and C is equal to 12. Again, the same equation of variation. So A is equal to, our k now it's 4, B is 6 cube over 12. So A is equal to 4, 6 cube, that is 216 over 12. So A is equal to 4 times 216, that is 864 over 12. So A is equal to 864 over 12, that is 72. So our A here is 72 when B is 6 and C is equal to 12. So I hope you've learned something about joint and combined variation this morning. Thank you so much.